Hello, and welcome to a Health Podyssey. I'm your host, Rob Lott. Friends, it's another very special episode of the podcast where we look beyond the authors of specific health affairs articles and welcome a guest who's making their mark on the health policy landscape in creative and thoughtful ways. A guest who can maybe help us look at something familiar and see it in a new light. And today, I'm thrilled to welcome to the pod Dyson, the leader of ChallengeWorks, which runs challenge prizes aimed at supporting innovation across the scientific fields, including healthcare. In just a moment, we'll hear a little more about what that work means in practice. Previously, Tris co-founded and led a social enterprise organization called Spice, which developed time credits as a low-cost and sustainable methodology for engaging people in communities as active participants in public and community services. I can't wait to hear about his experiences and his vision for challenge prizes in health and health policy. Dyson, thanks so much for joining us today.
It's a pleasure to be here, and thanks for the lovely introduction.
Absolutely. Well, let's just dig right in. ChallengeWorks is a project of Nesta, which is, if I'm understanding it correctly, a sort of British social enterprise organization. Can you tell us a little more about what that is and sort of how you ended up where you are today?
Yeah, so Nesta is the UK's innovation foundation. So it has an endowment of about £500 million, which is relatively small in foundation terms. I remember we had a visitor, Mike Bloomberg, came along a few years ago, and he called our endowment cute. But nonetheless, it's enough to kind of live on. And the purpose of Nesta is to support and promote innovation for public benefit in the UK. I run, as you said, ChallengeWorks, which is a subsidiary of Nesta, as part of the Nesta Group. And we specialize in challenge prizes, and these are mechanisms to create innovation contests and competitions to solve meaningful problems using science and technology.
Got it. Well, I want to ask a little more about sort of challenge prizes generally, but before we do, maybe we can start with a specific example to give our listeners something to kind of hold on to dig their teeth into. This summer, you just launched what is called the Longitude Prize on ALS. Tell us a little more about that. What's the goal and how does it work?
Yeah, so it's called the Longitude Prize because the original Challenge Prize, which was 300 years ago, was a contest for how can you find a way of measuring longitude at sea. And nobody could figure it out. Galileo, Newton, lots of people had tried. And so they launched a big contest, and that came up with the chronometer, the H4 chronometer, which obviously changed the world. We are the kind of the Longitude Prize series has been reinvented in the modern era to solve similar sort of sticky problems. And as you say, we've just launched the third modern Longitude Prize, and this time it is focused on ALS. People in the United States may know it as Lou Gehrig's disease, after the famous baseball player who came down with the condition. And it's known elsewhere as motor neurone disease. But I think that the image that people will probably recognize is Stephen Hawking. That's what he had. With Stephen Hawking, it took a long time for it to finish him off. But for most people, it's much shorter than that. But it's essentially a disease of sort of progressive paralysis followed by death. And there are no treatments, or at least none that are to be particularly commented on. And since the disease was discovered 150 years ago, both the diagnosis and the treatment of the disease hasn't changed. People essentially watch you twitch, and the treatments, as I said, are really nothing that has any serious effect. But we think that's about to change, and this is because one of the problems with ALS, as with other neurodegenerative diseases, is that it's extremely complex, and it's been very hard for people to grapple with, researchers to grapple with. But as Stephen Hawking predicted at an event in Google in 2015, AI is now at a level at which it's able to handle that level of complexity. And at the same time, the data is now available for the AI to interrogate in order to start to come up with solutions. So basically, the prize is that it's saying, can you find, here's a huge amount of data that we're making available, both American, European, Australian, international data that be made available to participating teams and money. And the job is to identify targets that could then ultimately become drugs. And the overall prize pot is $10 million, and you get an increasing amount of money the further you progress through the competition. But obviously, teams get knocked out as you go along. That's it.
Okay, great. Let's dig in a little bit on the process. This sounds kind of fun. Is anyone welcome to join the project? What do the milestones kind of look like? And at the end of the day, how is it determined whether or not someone sort of achieved the goal?
Yeah. So the first milestone is December the 3rd, at which point...
Like 3 months from now, 2 months from now.
Yeah, that's right.
Okay.
So that's how long teams have got to apply. You can come from anywhere in the world. You can be for-profit, not for profit, doesn't matter. And we will select 20 teams, and those teams will get, it's about $135,000 on the current exchange. And they'll get 9 months and access to this data, plus they'll get compute and a bunch of other stuff to look for targets. They then need to start to hypothesize around which of those targets will have the greatest potential. And then the following year, we will down select to 10 teams. And those 10 teams will get, it's about $250,000. The exchange rates change, so it's probably a bit more than that. And they will need to prioritize those targets and look for how druggable they are. Again, largely in silico in data, but also probably some lab work needed at that point as well. And then we go down to 5 teams. Those 5 teams will get about $750,000, something like that. And then they will move into the lab. And if they are highly competent on the AI, but not so competent on the lab work and the research work, we will support them to match up with people that can help them on that. And then the job in the lab is to demonstrate the potential druggability of those targets. And then there will be a winner, and the winner will get £1 million. So $1.3 million, something like that. But really by that point, we should be feeding pharma and investors, and, so that should really start to take off at that point.
My understanding is that you have a very personal connection to this particular challenge as well. Can you say a little more about that and how it's sort of shaping your approach in this space?
Yeah, well, I mean, I'm one of the unfortunate people that was being diagnosed with this disease. So I was diagnosed about 2.5 years ago. You can imagine it's quite a shock. I was told that I had 3 to 5 years to live, which seems wrong now, fortunately. But that's the kind of average. I mean, some people go much more quickly than that. Some people it takes longer. And yeah, I'm sort of working innovation all around the world in all sorts of different technologies and sectors. And I was quite amazed that I was seeing a consultant in London who was basically tapping me with a lollipop stick and then told me that there's no treatment. And it doesn't matter where you are. I mean, in the US, you've got a couple more licensed drugs than we do in the UK, but they don't really work. So it's not great wherever you are. And so, I mean, that made me realize that this really needed some impetus and some new approaches and models. It has to be said, though, there are things already starting to happen. So we're kind of at the beginning of a new wave, I think. And partly this is because there's so much data available now that wasn't true 10, 15 years ago. Funded. You might remember the Ice Bucket Challenge. That was the kind of example from your side of the Atlantic of someone raising money for research. Well, a lot of that went into data collection. So the data's significant, but also we're starting to see progress. So there is a drug now on the market called Tofersen. I think the brand name has actually changed, but anyway, it was originally called Tofersen. I think it might be called Corsoldi now. I don't know. Anyway, and it was a Boston company that for a very small group of patients, about 2% that have this inherited particular gene, SOD1 gene, it essentially more or less stops or severely slows the disease down. And it's a remarkable change for these patients that, otherwise had a death sentence completely. And you're also starting to see drugs come through in Alzheimer's and other neurodegenerative diseases that they're not knockout drugs, but they are progress. And so it's the change is happening now, basically.
Well, that's a good segue, I think, to sort of think about how this project fits in the kind of bigger structure of how we approach drug development in the US and around the world. I think the sort of typical approach, if I could broadly and probably aggressively oversimplify things, is the typical approach is basically a combination of like public sector grants to scientists conducting basic research. And then as that science kind of develops and gets more sophisticated and moves further down the pipeline, private investors step in to fund research and clinical trials, generally with the aim of returning or getting a return on their investment. Is that a fair description of the process? And I'm wondering if you can say a little bit about how that's maybe fallen short, especially in terms of rare diseases like ALS, but many others.
I mean, I think, the problem so firstly, ALS is a rare disease, as you said, but it's a rare disease because the patients die so quickly. So there aren't that many patients around. But actually you have a 1 in 300 chance over the course of a lifetime of getting the disease. So it's not common, but if it was treatable, it would be more like something like MS, for example. One of the problems there has been for drug companies is that there are not highly credible targets for them to get behind and develop drugs around. So they haven't really been, until recently, coming out of the universities, out of basic research. And so it's been quite hard for pharma to decide to invest in it in a significant way, with some exceptions. And again, the problem with that is like the basic research that was coming out of the universities. Firstly, it's not been very well funded. A lot of it has been funded through patient and public advocacy. But secondly, it's extremely difficult because it's a highly complicated disease, as with all neurodegenerative diseases. but also because it's in the brain, you can only really properly look at the brain when somebody's already dead, basically. So that's a huge problem. But these things are, as I said, significantly changing. Like the level of understanding in universities across the world, and significant number in the US, is way more than it was 10, 15 years ago because of this research that's been funded through the patients and public advocacy. And the understanding of the disease is really so much better. So there's got quite strong foundations. And I think the other big difference is what AI can do now with big data sets in terms of improving target and drug discovery, making it much more accurate and reducing the costs because you can do it quicker. And that should start to change the formulation, the economic formula for pharma and biotech. I think the other thing you're seeing is with some of the AI first biotechs in other disease areas, in some cases they're bypassing pharma. They're just going straight to drug development. Again, because the cost equation is significantly different. So we're at a moment in history where things are changing very, very rapidly. And there's lots of things to be concerned about from the point of view of AI, but in healthcare and in drug discovery, it's transformational.
Well, that's some really interesting sort of context in terms of both the areas where traditional approach falls short, but also we're seeing a lot of opportunity or maybe some transformational innovation that's going to sort of change the outlook going forward. Now let's plug in challenge prizes. How do those sort of fit into this new universe? How do they represent an alternative to kind of the old approach?
Challenge prizes have been around for, as I said, 300 years. The original prize was this longitude prize. And there's lots of examples in European history of challenge prizes that have completely moved the needle on a technology and have helped to kind of transform a new industry or sector. More recently, things like transatlantic flight, that was an American European prize, or set of prizes, or a bunch of prizes. But up until the kind of mid part of 20th century, like it sort of fell out of favor. It stopped happening. And it was the US that really, in the latter part of the 20th century, kind of fell back in love with challenge prizes. And there are examples, you've got X Prize on the West Coast. Their most famous prize was just after the millennium, which was like if you could put a spaceship into orbit, a suborbit, and back onto Earth with 2 passengers over the period of a week and do it twice, you'd win the Ansari X Prize. So that was a big moment. And then the US government have done lots of these challenge prizes, like DARPA have used them a lot around, like the autonomous self-driving cars basically came out of a bunch of challenges that was run by DARPA, that are now sort of huge, companies on the West Coast. So yeah, I mean, like it's a stimulus. It's a way of kind of provoking. You put a problem in front of innovators, whether they be entrepreneurs, scientists, technologists. You give them a bit of money, you give them some publicity, you give them support in the form of data or whatever it might be, and everybody loves it, and they all think they're going to win, and you go, and you wind up with a winner. But the sums of money are not huge. But they don't need to be, because you're getting over a valley of death, and at the other end, if you've got the problem definition right, there's a big market and a big opportunity on the other side of it.
Great. Well, in just a moment, I want to ask you a little more about what makes something a good fit for a challenge prize. But first, let's take a quick break. And we're back. I'm here with Tris Dyson talking about challenge prizes. Just a moment ago, you talked about some of the history and some previous examples we've seen over the last few years. ChallengeWorks is sort of maybe supercharging some of those opportunities and kind of raising the kind of attention level to some of this work. Is there a way to scale this opportunity? Are challenge prizes a sort of long-term viable opportunity for spurring research beyond just, a kind of interesting or fun project here or there? What's stopping, governments from making this a much bigger part of their innovation strategies?
I mean, the US has in the past used them more than we have in Europe anyway. Mm-hmm. Within the White House, within the Office of Science and Technology Policy, there used to be challenge prize people, and then different government departments, DARPA, NASA use them quite a lot, have used them, but they tend to be the more innovative agencies anyway that do them. I think they are not as widely used as they might be. I mean, you think in crude terms, it's payment on results. You took the Ansari X Prize example. If you didn't get the spaceship up into suborbit, you don't get the $10 million. So it's quite good value for money. There are other sort of related funding mechanisms that are bigger, that are similar. So you have kind of advanced market commitment models and procurement that's run much more like a sort of challenge prize contest. They tend to be a little less exciting, and the public don't sort of get behind them that in a kind of way, but the mechanism's similar. In Canada, there was a big proliferation of challenge prizes under the last Liberal government that was run out of the Canadian government. And obviously they've re-elected a Liberal Prime Minister, so that might well continue. And they do use them across government. It's been a bit slow. It's more sporadic in Europe. It is kind of, it's seen as a Rolls Royce. It's seen as quite a sort of splashy and kind of, garish kind of thing to do, and not as sensible as good old fashioned grant funding. But it is quite bizarre, because if you think grant funding involves a bunch of people sitting around a table, stroking their beards, deciding who to give the money to. And basically that will often mean that the money goes to like the usual people, Harvard, Yale, Oxford, Cambridge, and others then don't get a look in because they're basing it on track record and prestige and all that sort of stuff. And one of the reasons I think it's not changed significantly, like it is still 99% of science funding is grants, is because there's a very strong lobby group in the science community that quite like their grants.
They're used to the way things are.
Yeah. Particularly if they're at Harvard or Oxford University or whatever it might be. And it just comes down to political will and how interested the politicians are in it. I mean, under Obama, you might remember Biden wanted to do an enormous challenge on cancer. I think it was like $1 billion or something like that. So, sometimes you get these politicians who kind of really want to bite the bullet. I think where you do see it in health, or similar in health, is through the Gates grand challenges. Now they're much bigger and they're much longer term, but basically Gates will say, we want to get rid of malaria, and then they'll have sort of incremental funding for sort of breakthrough innovation that sort of addresses that goal, and they got a number of those. And that model has been picked up more and more internationally by health and development agencies. Yeah.
Well, it's about time for us to wrap up. But before we do, I want to sort of maybe get your pair of fresh eyes from the UK on sort of the current state of play here in the United States. We've seen obviously a sudden and dramatic shock to our biomedical research enterprise in the form of cuts to NIH research grants, layoffs at our public health agencies, a much more hostile stance from the administration toward institutions of higher ed. Less well covered, I think, is the damage that we're seeing to the pipeline of young researchers who may just be getting started today, but they're the ones we're counting on to be running these projects 10, 15 years down the road as principal investigators. Now, in sort of the state of the funding universe here in the United States, these researchers may be having second thoughts, wondering if it's worth going into these fields at all, especially when it comes to rare diseases. And so I'm wondering what you might say to a young researcher just starting to enter this field who's maybe just beginning to think about their career. Why should they go for it? And sort of what is the opportunity down the road that you might pitch to them?
Well, I mean, I don't think I understand that there are the problems that you listed, and they're pretty bad. But I don't think these are long-term problems because they can't be. And it's less dramatic, but in Europe, we've also had funding issues. And, our economies haven't been doing very well. And so there's just less money around. But the development of, all of our science and technology is built on our research institutions and our universities. And it's if those things are not continued and invested in some form or another, everything else is going to go wrong. So I would have thought that these are definite problems, but I would think they must be short-term problems, because it would be completely counterproductive for the US to seriously divest from research. You've got the world's leading research institutions. So if I was a student, I think you've got a bumpy couple of years, mate. I think I can't imagine it would be worse than that. And I mean, look, we've been since the financial crisis, Europe has flatlined and America has completely, gone way beyond us. And that's all because of your tech companies. And those tech companies are built on the foundations that come from your research institutions and your universities. And health, biotech is the next really big revolution. We can see what's happened with cancer is that in many cases it's become almost a chronic disease, and that's happening more and more and more. But there's a new revolution coming, which is this AI-powered revolution, and it's going to open up neurodegenerative diseases and other diseases in a way that's just not been possible. And the world's going to look very different in 10, 20 years' time because of that. So you're entering an area where there's huge growth, where there's huge potential for social impact because you can affect people's lives dramatically. And where in the long term, there's going to be lots of money sloshing about, even if there are some short-term challenges, I think.
Great. Well, an optimistic note to end on. We'll definitely be following your work and the efforts at ChallengeWorks. Tris Dyson, I had such a great time chatting with you today. Thanks so much for joining us.
Oh, it was a pleasure. Thank you.
To our listeners, if you enjoyed this episode, please recommend it to a friend, leave a review, and of course, tune in next week. Thanks, everyone.
Thanks for listening. If you enjoyed today's episode, I hope you'll tell a friend about the Health Podyssey.